There we go. Well, hi, everybody, and welcome to 605.603. This is Kotlin programming, object-oriented and functional programming. Hopefully everybody is in the right class. If not, leave now. No, hopefully, stay on, have fun, enjoy the class. So I'm going to start the class off here by just going through some logistics, just the boring stuff out of the way. And then we're going to talk about how we install our development environment and how we actually start programming some code in Kotlin. So logistics first here. First of all, this is my contact information. I'm Scott Stanchfield. You can reach me at scott.stanchfield@jhu.edu, and there's my phone number. Please restrict phone number usage to 9 a.m. to 9 p.m. If you're going to use it. When you're trying to contact me, I really prefer questions go to the forum on Canvas. So let me pop over Canvas here for a second. So on Canvas, underneath discussions, there's course feedback and assignment discussion. Just any questions you have, go ahead and put in the assignment discussions. And if there's anything that's of a personal nature, like if it's related to grades or related to something that's really specific to your assignment, like the actual code itself, then feel free to send me an email on that. Let's see, it's back to the slides over here. Where are you? There we go. And this is me. I've been a developer since 1989. That's when I graduated Michigan, and go blue. During that time, I did a whole lot of different development in different languages, things like PL1, assembly, Pascal, C, C++, C-list, Rex, all sorts of crazy things. And then finally got into Java. And once I was learning Java, I ended up becoming a Java instructor, flying all over the world for about 4 years. Now my favorite language is Kotlin. I mean, surprise, surprise. And if you already know Java, then you're going to have a bit of a heads up here. I'm going to teach this from the point of view of you don't know Java. But once in a while, I will actually do some comparisons of Kotlin to Java. Well, quite a bit. I'm going to do some comparisons of that. But you shouldn't have any problem if you're not familiar with Java. Is there anyone in the class who's not familiar with Java? I mean, for most of the programs here, we like you to all know Java. Okay, so I'm not seeing any hands go up or anything. I've been teaching at Hopkins since 2002, so over 20 years now. Wow, it's amazing. I started with like kind of a mix of a bunch of different classes, but then started focusing on design patterns. That was my main class for a while, and then got into Android, and I've been teaching Android for 10 years now. I think about 10 years, and I've been loving it. Doing all sorts of crazy things. Right now, my day job is I'm an Android developer relations engineer at Google. And that generally means I get to create samples and create videos and do all sorts of articles and things on developer.android.com. And been enjoying it so far. So here's a bunch of pictures of me. This first big one here. I've got one more person I got to admit. The big one there was when I was in the drama club at the Johns Hopkins Applied Physics Lab, and we were just goofing around while the firemen were trying to clear the building to make sure that the alarm didn't really mean anything. And then down below that, this is me in the trees, just kind of wandering around. This is me dancing with my dad's girlfriend. I love to swing dance. That's one of my favorite things. This is me riding roller coasters. This particular one at King's Dominion is a lot of fun, but they put the camera right at a spot where you get this big blast of air, and so like everybody has these great faces. And then this last picture over here was me when I was Brother Berenstain Bear at Cedar Point. That's when I actually learned I really enjoyed the roller coasters. But that was a fun summer, running around in a costume and hugging kids all day. I've worked for some famous people, and I do like to name drop, so I have to call them out. If you're familiar with the concept of cyclomatic complexity, that was created by a guy named Tom McCabe, and I worked for him for a couple years. After that, I moved out to California, and I was working at Metaware, which is a C++ compiler company. I was on the ANSI C++ committee for the last 2 meetings they had, so don't blame me on that one. But Frank Dreamer and Tom Pinello, the people who ran that company, are actually the ones who came up with the concept of LALR parsing. So if you've taken a compiler class or if you've used tools like Lex and Yak, those use LALR parsing, and they invented that. Really bright guys. I really enjoyed working with them. But Terrence Parr, the guy who created Antler, which was originally known as PCTS, he ended up becoming a good friend of mine. I was writing a debugger for Antler at the time, and he asked me to come over and do Java training for him. And I'm like, okay, that sounds like fun. And so then I started flying around and doing Java training. And Terrence actually works at Google now as well. What I'd like to ask everybody to do is please, please, please check SYS. Make sure that your email and your phone number are correct on there, because that's how I'm going to contact you. The main reason I want to contact people through this is, if for some reason I can't hold a class. So if I'm sick, for example, or if there's any type of announcements through Canvas. I'll usually do announcements in Canvas, and that information they use SYS to get a hold of you. Now, if you've already gotten the welcome announcement, that probably means your email's fine in SYS. But please also make sure your phone number is correct, because I'd like to try to notify people if for some reason I have to cancel the class. This isn't quite as important because it's not a live face-to-face class, because for that I hate to have people drive up and come to the classroom and see a note on the door saying instructor sick. But yeah, please have your information correct. That makes life a lot easier here. So let's talk a little bit about grading. This course is going to be based on programming assignments and 2 exams. The programming assignments are going to take up 70% of the grade, and the midterm and final are combined 30%. They're 15% each. What I do with the programming assignments is I look at the assignment, and as a whole, I decide what I think the grade is worth. So, whether it's going to be an A, a B plus, a C, whatever. And then I convert that into a number. Now, the number you're going to see inside Canvas is going to be a GPA style number. So it's going to be on a scale of 0 to 4. What that means is when you take that number and the average of it, it's going to give you some kind of percent. Don't worry too much about those percents, because those percents are going to look kind of bad. I mean, if you ended up having a B on assignment, it might look like with the normal percent scale that you got a C. The normal percent scale doesn't quite apply. Take a look at the syllabus. Ooh, did I update the syllabus for this class? Let me take a quick peek here and see if I updated the syllabus. I know I did it for the Android class, but I want to check in here and see if... ooh, they like wiped everything out. It's like empty. I'm going to update the syllabus. Sorry about that. I don't know why it's completely empty, because I had things in this before. But I'm going to have the grade scale in there that shows you how the reverse works. So just keep in mind that it's based on a 4-point. Don't get shocked if you see like a 75%, because that's actually a B. It's not a C. But hopefully everybody in here is going to be getting 100% or 90% or 95 or whatever. So I'm going to do those grades. I'm going to give you comments, but I'm not going to specify which things cost which points. In the past, I had done this, and the problem is that everybody spends time arguing about 1 or 2 points on an assignment, which never makes any difference. So I went with this idea of holistic grading, where I just take a look at it and say, overall, this is worth this grade, and then here's the reasons why I chose that grade. Keep in mind that each day late is a full letter deduction, so that's 1 point off of that 4. Midterm and final, I'm going to curve them up if needed. That's basically kind of the safety net. Like if for some reason when I write the exam, I wrote something in a weird way that nobody understood, or I referenced something that I didn't actually talk about, I can curve it up to say, okay, everybody missed that question. It probably means I did a bad job. Your final grade is going to be either A, B, C, F, or incomplete. Will not have a plus or minus. There was a lot of confusion when I first put pluses and minuses in this, especially when people were applying to a PhD program or when they're talking to the company who's reimbursing. A lot of times, like a company wouldn't know what to do with that plus or minus. So, if they had a B plus, they're like, well, that really counts as a B, so we're just going to count it as a B. So general grade guidelines. Now keep in mind here, this is saying things that will probably put you into this grade area, but it's not saying if you get a B, this is what that meant. So think of it kind of going from right to left here. So if your code was on time, working, and has a good design, you get an A. If it's not quite working, or there's some kind of design issue, or maybe you didn't quite follow what I was talking about in class, or it was an A and you were a day late, you get a B. C is really what happens when you start like at the very last minute, or you turned in something that's very incomplete or doesn't compile or doesn't execute properly, or you get the time off penalties on that. Um, F is typically not happening unless you're breaking the academic code. Please, 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 and I'm going to talk about it in a little bit here. Please do your own work, and for this class, the assignments really aren't that hard. So please do your own work. Don't work together on them, and make sure you turn them in. I mean, if you don't turn it in, it's an F as well. So here, let's talk about academic integrity a little bit here. All the work must be your own. Anything that if you happen to grab something online, which for this class you probably won't, but if you do, make sure you attribute it, and I'll talk about that in a minute. The type of ways you can work with each other. You can discuss the lectures. So if there's like something I talked about in a lecture and you want to talk about, well, what did he mean by this? Or, maybe one of you doesn't get it and the other one does, and you want to try to re-explain it. Hey, that's great. That's fine. Or if the assignment descriptions, if you need, if you want to talk through what the descriptions are, that's fine. But as far as actually doing the work, you can't work together on the assignments. Don't show each other code. Don't talk about how you would write the code. You can just talk about the concepts in the class and the things that I went over. Um, if you violate the academic policies, it's going to be a 0 on that assignment at the very least. There are some times where it can be worse. Like I've had people in the past where I found out on the 4th assignment they had actually plagiarized all 4 of them. And that one in particular went down a very, very bad path, ended up in an academic hearing, and it was not a pretty result. So please just do your own work. That's really all it takes. Do your own work, and you'll do fine. Um, Now, this also, if you copy stuff without attribution, that's called plagiarism. So don't plagiarize. Do your work. Don't turn in somebody else's work as your own. Um, if there's any other type of misrepresentation of your work, and that's just, I know it's kind of vague, but in general, that means that it's like you're trying to say, hey, here's work that I've done and you didn't. Now, note that this doesn't just apply to final submissions. If you're working on an assignment and you send me some code and say, hey, I'm really stuck, can you kind of help me out here? I'm going to be looking at your code to try to figure out what to do. And I did have an instance where somebody turned in something early to have me help out, and they had plagiarized that. And so I gave them a 0 on it before they submitted it. And they argued that, well, I haven't submitted it yet. And it's like, you're still representing somebody else's work as your own. And for the assignment, that counts as a 0. So to attribute your code, pretty simple. I'm not going to ask for anything big here, but in general, most of the code, if not all the code that you do in your assignments, should either be stuff that you've written yourself or you've copied from a class sample. If you find something online and you want to use it, there's really 3 things that you have to do. First of all, make sure it has a license. A lot of stuff online doesn't mention anything about a license, and this is reminding me that I need to do that for my javadude.com site. Um, if the license is something open source and non-viral, so not something like the GNU public license or CC by SA, which is Creative Commons with attribution, share alike. And what that one means is that you have to license your code CC by SA as well. Or if you copied in some GPL, you'd have to license your code GPL as well. And in particular, that's really bad news for companies. Companies do not like to do that. But if it's something that's a good open source license like Apache 2, then all you need to do is attribute it at the point of use. Or if there's a lot of them sprinkled through the file, put a comment up at the top of the file. This is typically how you might do it down here, where it came from, what license it was, and then an end of copied code. Stack Overflow is super, super helpful, but in real life, be super careful of it. The big problem is that Stack Overflow is licensed CC by SA by default. Now, sometimes you'll see inside of the code itself, you might see a little header that says SPDX and then a name of a license. And that's a way for whoever wrote that piece of code to say that I'm licensing it under an additional license as well as this CC by SA. And this is something that the Googlers will do as well. So when I post something on Stack Overflow now, I put a little header saying this is Apache 2. copyright Google, it's Apache 2, you can use it. And that way, it's something that you're safe using from Stack Overflow. But if it doesn't have anything like that, keep in mind that it's going to be CC by SA. And if you copy it, that means that your code has to become CC by SA. And your company or the government will not like that. I've worked for several government contractors, and the government does not take that lightly. Your best bet is if it doesn't have that little special license note, is to say use a clean room approach. And basically what that means is you read the article in Stack Overflow, understand it, and then close that browser window. And then you write your code. And by doing that, you've gotten the concept, that's fine, but you're not actually copying the code that they did. Okay. Now, some of the grading guidelines that I use when I'm actually looking at your code, there's really 4 areas: design, function, style, and timeliness. For design, basically, I want you to use what I've told you and how I've told you to do it. You may find other ways of doing things online, but I'm going to be showing you certain patterns and certain ways of doing things. And those are what I'm considering best practices. And I want you to try to follow those rather than finding an example online that does something that we're asking for an assignment. I'm also going to be looking for, are you using abstraction effectively? So if there's something that, could be done super brute force versus being done in a more abstract or elegant way, I want you to choose the abstract or elegant way. And does the design you've chosen actually fit the problem? I mean, sometimes, somebody will have an assignment that it might be useful to use, let's say, a decorator pattern, and maybe instead they use an observer, which is a really weird fit there. But they're trying to force fit the wrong design in. Try to use what I've actually gone over in class. And then function's a really big part of this. I mean, does it work? And it's really important that all of the required function that I ask for is present. I've had people in the past say, well, I demonstrated that I understood things enough. And that's not enough. When I have the assignment description written, you need to fill all of the function that's listed in there. For style and coding conventions, basically, can I read the code? I'm going to talk about this in a little bit more detail in a minute, but mainly I want to be able to just look at the code and say, oh yeah, that makes sense. And then when I run it, that's just a verification. It's not a matter of just running it and making sure it works. It's, can I figure out what it does by reading it? And then timeliness, of course, each day late is a point off. For your assignments, all of your assignments must be written in Kotlin. Surprise, surprise. You wouldn't expect that for this class, would you? All of your assignments must be built using Gradle inside IntelliJ IDEA. So that means you're going to be giving me IntelliJ projects, and they're going to have Gradle scripts inside of them. You can turn in your assignments any number of times. I'm fine with that, but I'll only grade the last submission. Please don't ask me to grade whatever the best one is. For coding conventions, simple reason here why I have them is I read the code. And there's a bunch of different times that I might read this. It could be before the submission, so maybe you're asking for some help, and I'm going to need to be able to figure out what it means. Or once you've submitted, I read the code carefully to try to figure out why there's problems. And that can help me give you some partial credit. There's a lot of times when I'll go through, I'll read the code, and I'll tweak one line or two, and then it'll work just fine. You'll get a little bit of a deduction on it, but it's not as bad as if I couldn't figure out how to modify your code. So looking at the coding conventions, first thing is going to be leading indentation. Either choose spaces for all your leading indentation or choose tabs for your leading indentation. It's up to you. As long as you're consistent, I'll be able to read your code. That'll be fine. Please don't mix them, because then if my tab settings are different than your tab settings, it's going to be unreadable. For any type of type names, so we're talking classes, we're talking interfaces, we're talking enumerations. What's the other one that I was going to say inside there? Well, those are the main guys. You're going to be using upper camel case. And that looks like shopping cart or object drawing applet. Basically, you have full words. Each word starts with an uppercase letter. The rest of the words are all lowercase. When we're talking about variables or function names, these are going to be lower camel case. So it's the same type of thing, but the first letter starts in a lowercase letter. And this makes it really easy to determine a difference between these when I'm looking at the code. Whenever you're choosing a name, like a name for a variable or a name for a function or a class or an interface, I want you to use full words. Don't use abbreviations or single letters. Every once in a while, somebody gets really, really terse on their letters. And with Kotlin, it's nice to be terse, but you want to make sure you're understandable as well. This reduces how much commenting you have to do as well. If the variable names and the functions names actually read like something and it's understandable what they are, then it's going to be a lot easier for somebody to read your code. If it's a standard acronym like URL or HTTP or something like that, that's perfectly fine. You can use those acronyms. And if you have any questions on is this acronym is okay, send me an email. I can let you know, or put that on the forums. There are a few exceptions to this that I think are fine for just common usage. If you have an integer counter in a loop or something like that, I, J, and K, very, very common. Everybody gets it. If you have some kind of number that you're incrementing in a loop or something, N is good for that. And then finally, if you're writing a catch block for catching some exceptions, E is fine for that. If you have multiple catch blocks, or nested catch blocks, I should say, then using like an E1, E2, something like that would be fine. Okay, your project names, so when you actually create your project, which is going to basically be a folder containing all your code, are just going to be HW1, HW2, HW3, and so on. When you zip up your assignment to turn it in, I want you to name it your last name, dot your first name, dot HW1, 2, 3, whatever it is. Okay, I'm just double checking nobody's names are exactly the same. That's good. I did have that happen once. I had 2 Mike Smiths in a class one time. All of your package names, and these are basically namespaces, things that collect a bunch of code into a common group. We'll again start with your last name, first name, .hw1. But if you want to have other package names, you can extend those. So for example, if I was writing HW4 and I had a couple other packages I just wanted to group in some model code or some database code, I could just throw .model and .database on the end of that. But again, look at all of the packages are starting with my last name, my first name, .hw4. And finally, discussion participation. I love when people discuss things, when they have questions, but you don't have to. I mean, there's no required participation here. We're not doing any type of online forum that you have to answer every week or anything like that. But I ask for if you have questions, please use the discussion forums, and then if it's private, email me. If it's in class time, feel free to just pop up at any time or raise a hand, whatever you're comfortable with. Make some comments, suggest alternatives, give me feedback as you go, whatever you want to say. And as far as course feedback is concerned, I really enjoy having feedback so that I can improve this course from term to term. So if you have things you want to say along the way, that's great. If you want to wait until after you've gotten your grade and send me an email, that's great. There's also a discussion forum where you can put in course feedback. Okay, so that's all for that. Any questions on anything so far? I know I really haven't said anything. It's like, yeah, you just didn't say anything. All you did was talk about grades and stuff. Okay, so let's take a look at how we're going to set up our environment here. And I believe I've completely uninstalled it from my computer, so we should be in good shape. The way you're going to want to do this is just search for JetBrains Toolbox, and that should take you to JetBrains.com's Toolbox app. So we'll go inside here, and I'm going to go ahead and say, yeah, I agree with your stuff. And what we're going to do is, depending on what platform you're on, you can choose a different download. It should default appropriately. I'm going to go ahead and download that. And let me move this over here. And okay, so that looks good. So when you've done that, that'll go to your downloads folder or wherever you specified to download it. And then we're just going to run that. Obviously, I'm running on Windows here. Your different platforms are going to have slightly different effects, but in general, it should behave the same. So I'm going to go ahead and install. La 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 la. And I'm going to run him. And what this is going to do is place an item on your system bar, at least on Windows. Let me see if I can go like this. There we go. So we'll see that this added this little icon down here. Hopefully everybody can see that. And when we tap on it, it's going to give you the kind of little welcome spiel. And I'm going to say, yeah, continue. It can optionally decide if you want to actually send any type of feedback about usage to JetBrains. Typically, the things that they do here is basically keep track of, how many times a given app was run. I'm going to just go ahead and say accept license agreement. You can choose which type of theme you want. I'm just going to let it tie to the system theme for dark or light. And you'll see something that looks kind of like this. And these guys, he should have been uninstalled. There, now he's uninstalled anyway. Okay, so what we're going to do is we're going to install the application. You're going to scroll down until you see IntelliJ IDEA Community Edition. This is a free edition of the tool. If we were doing something more advanced in this class, I would have set up an educational license here. But the type of stuff that we're doing in this class, the Community Edition works fantastically for. So hit install on him, and this will download and install the latest version. If during the course a new version is released, and they just released a new version in the last day or two, if a new version is released, please do not update it unless I ask you to. Okay, and here he goes. He should be done and about there. There, hey, perfect. Okay, so once it's run, or once it's installed, go ahead and click on it to run it. And let's see if I can put this back where it should be. That looks about right. And again, it's also asking you here, do you want to send any type of statistics and things today? I'm going to say no. And here's what you get when you start IntelliJ IDEA. So the first thing we're going to do is create a project. So I'm going to say new project. And I'm going to call this one week 1. I'd like you to call it HW1 like that. You can put it in whatever directory you would like here. I'm going to change that to my Kotlin directory here. There we go, Kotlin Spring 2024. Okay, and then I'm going to say week 01. I'm going to change this to be week 01. And the language that we're going to be using here is going to be Kotlin, not Java. The build system is going to be Gradle, and JDK 17 is great. IntelliJ should come with that built in, so you wouldn't have to actually download it separately. And then for the Gradle DSL, DSL means domain-specific language. This is a little language that we're using to actually configure Gradle. And we're going to use Kotlin for that. I'm going to go ahead and let it add sample code and generate code with onboarding tips. The last thing we want to do is down here where it says advanced settings, make a little tweak here. So under group ID, I want you to put your last name dot first name. And I am going to say com.javadude. Just com.javadude. And then your artifact ID, this is basically saying which jar file is going to be created. A jar file is what's known as a Java archive. And this is a means of distributing your application. It's not really going to matter for the class, but we're going to want to choose that. And let's see, is there anything else in there I want to change? I don't think so. Go ahead and hit create. And here we go. Oh, this is nice. This is really new, this with the press shift 9 and stuff. That's pretty cool. I like that. It looks neat. I've got to figure out how to do that so I can put stuff like that in it in little annotations. That's nifty. I don't get impressed that often, but little things like that make my day. So once we've got this application in here, this is just a little sample main application here. So it's kind of like a hello world. What I'm going to do first, though, is I want to make a few tweaks to the settings. So you can go up to File and then Settings. And there's some changes that I'm going to make for me, and there's some changes in general that I would like to recommend you make. The first thing, let's see, I want to do is go up here and type in camel and go to Smart Keys. And there's these two options for camel humps. And these affect what happens when you double click on something or you hold down Control and use the arrow to move through them. And what I like to do is switch the two of these. I don't like the way that these are set up. Eclipse defines them a little differently, and I learned Eclipse a long time back. I haven't used Eclipse probably in 10 years now, but I'm used to the key mappings, and so I like to change to Eclipse key mapping. But these, I think, are really nice to be able to help you select variables and things. So I'm going to swap those and then hit OK. And let me show you what those do. Let's put in here a var some variable name, something like that. And watch what happens if I double click on this. Notice how it selects the entire word. If I hadn't switched those, it would only have selected the word variable inside there. And I prefer this just because this way I can copy a name and paste it somewhere else if I wanted to. Now, if I'm inside there, and if I hold the Control key and use arrows, notice how it jumps between each of the words that's showing up there. This allows me to do things like I can change part of the name pretty easily, like that. I can go over here, and this gives me a little bit more control rather than having to use my arrow keys and shift to select a piece before I do it. So that's the first thing I'd recommend is you change those two guys. And that's not just for me. I think you guys could get some use out of that as well. I'm going to go down to Editor, Code Style, and then Kotlin, because we're going to be using Kotlin in this class. And there's a couple things I just want to double check. I'm not sure what the defaults are in this version, but let's see. I'm going to go into imports, and yeah, unfortunately they're using bad values here. What I'd like you to do is change the imports where it says top level symbols, use single name import, and then Java statics in a new members, use single name import. And this is really important because using this star for imports is really a bad idea. And let me show you why. I'm going to go to javadude.com, which is my website. I'm going to go to articles, and in there, second article there, wow, 2004, 20 years ago. I'm going to go into this article, Import on Demand is Evil, and I'm going to explain really quickly why this is bad. If you're not familiar with Java, it's not going to be quite as obvious, but this is Java code, obviously, from 20 years ago. Kotlin didn't exist. And a lot of times early on, people would add import statements that might look like this, AB star and XY star. Actually, let me go to the real example. So here's a real example that people would do all the time in the very first version of Java. You'd say import java.util.star, import java.awt.star. And what these statements mean in Java is if I see a name that I don't understand. So if the compiler is looking at your code and you write the word list, and there's nowhere else in your code that you've actually defined what list is, it's going to go and take a look and see if it can find it in either of these packages. If it finds it in one of them, then it's going to assume that the list you meant was java.util.list or java.awt.list. If it finds it in neither of them, it's going to tell you, I don't know what list is. If it finds it in both, it's going to say, ooh, that's ambiguous. I don't understand what you're talking about. You need to be more specific. And you need to explicitly tell me which list you want. Something like java.util.collections.list down here. So in Java 1, the very first Java that came out, the first JDK, list only existed in java.awt.star. And so if you wrote this code, the compiler would be perfectly happy. It would say, hey, I know what list you're talking about. But let's say that you have your program running, you've released it, you've checked your code in. Maybe a year later, you come back to make some modifications to it. You check it out. We've now hit the next version of Java, which happens to have added list to java.util, as soon as you open up your code, it's going to complain that this is ambiguous. And it's bad enough if you were the original developer and this is a year later and you're trying to remember what's going on. But if you're a different developer looking at this, you're going to like, why did somebody check in code that doesn't work? So it's in a case like this, instead of using the star format, what you want to do is explicitly say java.util.list. And by doing that, then you've hard coded into your application or the source file that that's what you mean when you say list. And then that will remain fine over time. You won't have any of these issues of conflicts. So don't use the .star format in Java or in Kotlin. Okay, and let me go back over here. So we're going to change those two. And then down at the bottom where it says package use import with, I'm going to hit minus until they're all gone. So we don't want anything inside there. Okay, this stuff at the bottom is perfectly fine. I'm just going to hit apply there. And let's see what else I want to do inside there. So the key map. Let me set up the key map here. And you don't have to do this. If you end up liking the key map that comes by default, feel free to use it. I'm just so used to Eclipse, and I've been using the Eclipse key mapping for years. I like to change it. There's some nice changes in there for me. So for changing this, I'm going to go to Eclipse, and I'm going to go to this little guy, well, actually, where is why is it not giving me the make a copy? Okay, hold on one second. There we go. That's weird because it didn't have this duplicate option there before. So I do need to tell you that IntelliJ and Android Studio, which builds on it, are a little buggy here and there. It's gotten much, much better, but sometimes there's little things like this that happen. So I changed to Eclipse. I'm going to pick duplicate, and I'm just going to change this to be Eclipse with my initials there and hit enter. So now I have a copy of that key map. And I'm going to go over here and type move, come down to move line down and move line up. I want to define alt up and alt down for those. Note that alt up and alt down are currently defined for move statement down and move statement up. The problem with those is that that moves an entire statement, whatever that means, and however it's listed on the screen right now, as opposed to just dealing with individual lines. And individual lines, I think, makes a lot more sense. With statements, sometimes it would actually stop you from moving something somewhere if it didn't make sense in the outside context. So what I'm going to do is double click on move line down, add keyboard shortcut, and say alt down. And OK, remove the old version of it. And similar for line up. I'm going to go alt up. And regardless if you're using the Eclipse version or the IntelliJ, I'd really recommend you override these to make sure it's line up and line down that are doing it. And I can't remember if the base IntelliJ one even defines this. This is a great little function. I'm going to show you what it does in a minute. Okay, so I'm going to apply that. And let's see, the last one here, I'm going to do one more thing. I'm going to say editor tabs. There we go. There we go, editor tabs. So underneath here, there's this tab limit of 10. I'm going to change that to 100. And you can change this to whatever you want. This just makes it so that if I have more than 10 files open, they stay up in tabs as opposed to automatically closing things. Okay, so I'm going to hit OK on that. And now let me show you what that move up and move down did. First of all, I'm going to duplicate this line. And I can do that by holding Control Alt and then hit down. That makes a duplicate of it. If I had multiple lines and hit Control Alt down, it duplicates them there. But now moving them, those two lines are highlighted. I can just hold Alt and I can move them up and I can move them down. Ooh, wow. Well, that was fun. I mean, that annotation stuff that they were doing obviously is keeping track of line numbers, and let me undo that so it goes back to the way it was. Huh, interesting. Let's open him back up again and see what happens. Okay, now they're doing that. That's weird. But anyway, the way that you can use these is you can move things around, move them up and down, and it makes your editing super fast. You'll see when I'm doing things that I'm going to use that quite a bit, especially things like if I wanted to do I and J there, I might duplicate them a couple times and then just make a couple tweaks. And that's much, much faster than highlighting and hitting Control C, Control V, that type of thing. And then Control D, boom, deletes things. Okay, so let's see, was there anything else I wanted to tweak in that? No, I don't think so. Anyone have any questions so far? Okay, and I'm going, oh, go ahead. Yes, yeah, I was just about to talk about that. I was thinking about 8:30. Do people need a break now? And let me say, if any point somebody's eyeballs start floating, please let me know, and I can put a break in at any point. If I don't break by 8:30, please let me know, because sometimes I'll lose track of time. I love to hear the sound of my own voice, and I just go on and on and on and on and on. I have been known to lecture for 3 hours straight, and then people at the end of the class just running for the bathrooms. But yeah, let me know if there's any issues. Okay, any other questions? Okay, so that's our startup there. And let me see what I wanted to talk about first in here. So let's try running a program. I'm going to actually tweak this code quite a bit here just to get it down to just a very simple hello world. So I'm going to delete that little tip there. That's so cool. I really like that. Delete that stuff. I'm going to say hello world. There we go. So this is a very, very simple hello world program in Kotlin. We're defining a function, and this function acts as a top level function. If you're used to Java, you know that your functions have to exist inside of a class or an interface. But in Kotlin, they exist at the top level, the file like this. And if I run this one, I'm going to see hello world printed. So let's take a look at how we can run it. There's a couple ways we can do this. You'll notice this triangle over here. When I hit him, I can choose run main KT here, and it's going to compile it and then run it, and we'll see, ta-da, hello world. So that actually worked just fine there. What's actually going on here? Now, the way that I have this thing set up is that we're running the Kotlin code on top of a Java virtual machine. You can run Kotlin anywhere a Java virtual machine exists. So you can basically use it anywhere you would normally use Java, which is fantastic. You can also run it in native mode. So there's a native compilation for it. You can also run it for multi-platform, which might compile code for Android and for Java and for JavaScript and for some native code on your platform. We're going to just be using it inside the Java virtual machine. The language itself stays the same across any place that you're deploying it, but it's going to be compiled into different types of binary formats. So here it's going to be compiled into a class file, and then that class file gets executed. Now you're going to notice over here, when I clicked on this, it says run main KT. Notice how the file name is main.kt, KT for Kotlin. This main KT is actually a class name that's being generated for running on the virtual machine. And it generates that just by taking whatever the name of your file is and then appending KT with the capital K. And then that creates a class. So this main is actually being carried inside of a class on the Java virtual machine because it has to be. As far as the language is concerned, this is a top level function. It just happens to be carried inside that for use on the Java virtual machine. Now this, the package is com.java dude. The code itself, typically we're going to have live in a directory matching the package name. And the package name is just a namespace to make things unambiguous. So if I had this top level main function in 10 different files, the package name here would be used to qualify it, and the package name would have to be different. In order for that to work, what we typically want to do is define directories that match the package name. So the top level directory would be com. Underneath it would be a directory called JavaDude. The layout in the project here, we're starting off with our top project here at week 01. You'll see that there's this source main Kotlin structure here. Source is where all of your source code is going to go. If I collapse that, we're going to see everything is left at the top level of the file. Most of this are build files, and we'll come back to those in a minute. Underneath source, we have things called source sets, and these are ways of grouping code for different purposes in your application. So the main one is your actual application code that's going to run. This test source set is a set of unit tests that can run parts of the code underneath main. So underneath main, we're going to have different types of languages available. So we have Kotlin. You could have Java in there, for example, as well. If you're running a project that has a mix of Java and Kotlin code, sometimes you have to do that because of legacy stuff and you want to keep it going, then you would use source main Java and put the Kotlin code in that Java directory. You could also have a source main Kotlin, but sometimes that gets confusing. Usually having your code in one directory, one language directory like that is fine. Now you can't go the opposite way. You can't put Java code underneath the Kotlin one. So if you have both, it has to be source main Kotlin. Now underneath there, we're going to create that directory structure. So I'm going to say new package com.javadude, oops, dot week 1. We'll say week 01. And so that created this little structure here. This is actually a directory structure, but it's putting it together just looking like the package name that we're defining. I'm going to move this in there just by dragging it in. And this is going to do some refactoring, so it should change the package name once it moves it in. Oh, well, that's pretty. Sometimes it's not as smart as it should be. So the package name should match here and here. So now the fully qualified name of this guy is com.javadude.week01.mainkt. And that's going to be important if we want to run this through Gradle. So let's take a look at our build.gradle.kts file. This is our top level application, application build file. And there's several things being listed inside here. First of all, a list of plugins. This is code that modifies the way the build works. So the Gradle build itself has some basic support, but we're extending it by saying I want to use the Kotlin Gradle plugin, version 1.9.22, which is the latest. And I'm targeting the Java virtual machine. So that's the type of code it's going to create. These are used if we're going to create any type of artifact to produce. The repositories are where I'm going to get any type of external dependencies. And we probably won't see those for a little while. We're just going to do stuff just kind of with the raw language for a while. Dependencies are what we're pulling in. So we're going to see here that this test implementation is using this Kotlin test library. So this is a third-party library that we're going to be downloading from a repository for our tests. So this one matches this test source set. And then down here, we're just setting it up so that for our tests, we're going to be using JUnit to run our tests as opposed to some other type of platform. And then finally down here, we're telling Kotlin, the Kotlin compiler, when you generate your code, I want the Java code to be compatible with JDK 17. So it's going to use that for the bytecode that's produced, and then we can only run that jar on at least Java 17 there. Now I'm going to add a little something in here. I'm going to come up to the top, and I'm going to say application. And application is a special plugin here. It happens to already have just a name we can use directly. This plugin lets you actually run some Java code. So I'm going to come down at the bottom here and say, let's configure application. And did I spell that right? Oh, I need to resync it. What's happening right now is it's red because I added this in, but IntelliJ doesn't understand that yet. I haven't told IntelliJ to reread this script and apply the application plugin. So I'm going to go over to here where this little elephant is and click on him. And what that's going to do is resynchronize, and now we see everything's fine. So now, anytime you make a change to these build scripts, you need to tell IntelliJ that you've changed them. Please synchronize so that IntelliJ can understand how to apply these things in the editor. So for application down here, I'm going to say main class dot set, and then I have to put in the fully qualified name of the class I want to run. So that fully qualified name is going to be that package dot main kt, just like that. And so I'm going to synchronize him again, just to make sure everything's fine there. And we're going to go to command line now. So I'm going to go down to his terminal, and I'm going to say /Gradle W space run. And run is a target that's defined by that application plugin. And so when I do that, we'll see that it built the application and spit out hello world. Ta-da! And he was mentioning here compiling and testing with Java 21 with Gradle 8.4. I'm not going to get into a lot of details on what's going on here because we specified 17, right? The thing that's happening here is there's actually about 6 places where the JDK gets specified during your build. And if you're interested in more detail there, I'm going to do a little shameless self-promotion here. If we go to developer.android.com/build/JDKs, this is a page that I wrote last summer that talks about the different Java versions being used in a build. In particular, this applies to Android, but most of this applies as well to just a normal Java build. So developer.android.com/build/JDKs, and you can see my wonderful writing. Yay! Okay, so we're going to come back over here. So that run, boom, told us hello world. So that's how we can actually run this from the command line. Okay, any questions on anything so far? Okay, so that's a lot of mechanics there. There's one thing I did notice here, just looking at IntelliJ, is this looks really, really old to me. I'm going to go to File, Settings. There's a new user interface that they added. There we go. So if you just search for new space UI, under Appearance and Behavior, you can check Enable New UI. And I think that'll be good like that. Go ahead and hit OK on that, and we're going to need to restart IntelliJ. That's better. I'm so used to this because I was like looking around like, hey, where's my terminal over here? And it was actually on the bottom. But this is a much simplified user interface here. And I'm going to keep it in dark mode. Finish setup. There we go. So that should be in good shape. Now there was a notification that popped up here as well. I'm going to go look at this notification, and we can notice that it says Microsoft Defender configuration. It's telling me here that my antivirus might be interfering. And what's going on here is these directories here are ones that are being used when I run the application. Because of that, if the antivirus is scanning this, it's going to make these things go quite a bit slower. Now, I'm pretty sure that my D drive, I set it up so that nothing on there, everything's excluded from the virus scan. So we should be okay here. But you can hit this automatic button, who's actually going to run a little script that actually adds these ones automatically. I'm going to go ahead and hit automatic. And you probably didn't see that window pop up, but it was the user access control window coming up. Now, this might appear different on other systems, such as if you're running on a Mac or on Linux. I don't even know if this pops up on this. This might only be a Microsoft Defender thing. But that'll greatly speed up your builds, especially if you have bigger applications. Okay, so I'm going to reopen the project view over here. Oh, that's better. That feels normal to me now. Okay, so let's actually start talking about some code. And I just got some slides from JetBrains, and they have some common Kotlin slides that they allow people to use. And I was looking through them, and I think I want to just stick with the way I've been doing this before. I may show some of their slides once in a while, but for the most part, I think they kind of jump ahead a little faster than I like to. So I'm going to go ahead and just keep going my normal way here. We have our Hello World running. Yay! Let's actually add something inside of here. Add some data. Come into here, and I'm going to say var x :int equals 42. This is what's known as a property declaration. And what I'm doing is I'm defining a property called x, and we could just call that a variable. But typically in Kotlin, we call it a property. There's certain reasons for that. And x is a variable property, meaning we can change it, of type integer, and the initial value is going to be 42. So fairly straightforward thing there. If I want, I can modify that. I can say x equals 10. Boom. I've now changed the value of x. And then if I print it out, I should see 10 printed out. Let's go ahead and run this. And there he is. Boy, he just took a little while. We see our 10 and we see our hello world. Now to rerun this, notice I had to hit click this thing twice. Once you've run that, up at the top here, we can see a little thing saying which run or debug configuration I'm going to run. And that's the one that is just main KT. And if I just hit the run button here directly, it'll run it without me having to actually pick it each time. And notice how much faster that run was because it's already been built. Okay, so that is a simple variable. Now we're going to be talking a lot about functional programming in this class, and one of the things you want to try to do in functional programming is make things immutable where you can. It's a lot easier to reason about things, and as we get more and more advanced with functional programming and systems that'll support it, if your functions are pure, meaning that there's no side effects to them and you're only passing in immutable data, they can actually be optimized to run concurrently and then join the results back automatically. Now, we're not to that point quite yet with Kotlin, but there's some support being built up that'll eventually get there. It also makes it much more easy to reason about your code. So when you're looking at some code, if all the data coming in is immutable and you're just returning a value, it makes it much more obvious how it's going to behave each time, and make sure that the code is going to be idempotent, which means that if you run it with the same values, you always get the same results. That's not necessarily the case if you have side effects. Like if you go in a function and then the function modifies some global data, or goes off to the network to get some data, or writes some files, reads and writes files. All of that would make it so you can't necessarily predict the behavior of the function. So to do that, we can use a value instead of a var and do something similar. And property declaration cannot write. I'm going to say here can write. Now there's a little bit of a difference between the concept of writing something and something not being writable and something being immutable. Immutable means you cannot change it. Not writable means you cannot use functions that tell it to change. But that doesn't stop it from being changed behind the scenes. In this particular case, this declaration that I've written is in fact immutable because I'm not overriding how the value is gotten. I'm explicitly saying, here's a val y, here's a value of 10, and there's no way to change him. So if I came in here and I said println, whoops, boom, there we go, println y. If I do that, I should be just fine when I run this. And we'll see we've had the two 10s being written. I should have probably picked something different for that number. Run it again. There we go, we got a 10 and 15, that's great. But if I try to say y equals 100, the compiler's not even going to be happy. And the lint check that happens inside of my editor is not going to be happy. Well, notice the little red squiggle there. If I float over him, it says val cannot be reassigned. And if you want, you can click on this change to var, and that'll modify it if that's really what you want. Most of the time, I would strongly advise you to think about making things vals instead of vars. Now, when we're dealing with object-oriented programming, we may have an object you can change values, but if you're doing stuff inside of a function, try to keep them as vals. It'll make your life a lot easier. Okay, so I'm going to write here, cannot do this. Yay. Okay, so let's see how we're doing on time. I got a couple more minutes here. So what I'm going to do now is extend these properties just a little bit. Each of these properties, when I say something like x equals 10, or when I say x, those are actually running something that looks like a function behind the scenes. And that function will either get the value of x or set the value of x. So let's just define some stuff out here. I will define a, let's call it simple property. Actually, I'm going to call this one redundant property. And what the redundant property is going to do, he's an integer. I'm going to start him off with a value of 10. But I'm going to explicitly define how I get the value and how I set the value. So if I put the word get here, and then a little piece of code, I can say return field. And then I can come over here and say set with a value, and I can say field equals value, just kind of like that. And what is he now? Oh, I've made it a val. Make that a var. There we go. These getters and setters are the default actions. I'll say default getter. And this is the default setter. Whenever you define a var, it defines a field to hold the data. And the word field here is just referring to a place where that 10 got stored. If your getter returns the field and your setter just sets the field, that's the default behavior. You don't need to define these. And if I float over these, you'll see it says redundant getter. Hey, I chose a good name. And this one says redundant setter. And these guys are telling you, you really don't want to write code like this. You don't need to. There's no value to it. But sometimes you actually want to do something interesting. Like let's say I came in here and I said val simple getter property. And then I come into here. Let's say that instead of returning field, I said return 10. Now notice up here, this guy is telling us initializer not allowed because there's no backing field. Now that tends to confuse people a little bit, but this guy here, the place where the data is stored, that's the thing called a backing field. And if you're never mentioning the word field inside your getter, or if you have a val, the getter or the setter, then there's no place to store the data. Kotlin looks at this and says, oh, you're always returning the same value, you're computing it. I don't need to have a place to store the data. So it doesn't define a backing field for you. So let's say no backing field. But if there is a backing field, note that if I comment this out, it's going to give me some errors here. It's going to say, hey, you have to initialize it. So if you mention field in your getter or setter, then you have to initialize it. If you don't have a field, then you can't initialize it because there's no backing field here. So this is like explicitly returning a value. And let's make a couple of these. So this one, let's say that I had this return some value. Actually, I'll just create a little function here. Let's say I did something kind of like this. So this particular guy here, I'm defining a default getter. Whoops, this is not default getter. What am I calling the default getter? Get them out of there. This one, I'm defining a getter that calls some other function to get a value. Now, because I'm not referencing field, there's no backing field, so I cannot initialize it up here. But I'm calling some other function to get that value. Now this other function could do anything in the world. And this is where we start seeing the difference between read-only and immutable. This is defining a read-only property, but it's not necessarily immutable. And I'm using the words there very carefully because in this case, right now, if we had the code like this, it really is immutable. It's really not something that's going to change. But this get value could do anything it wants. I mean, it could read this off a network. And because of that, this value could change. And it might not be idempotent because it could return a different value every single time. So we have to be kind of careful about things like that. The difference between read-only and immutable is whether or not your code can say, let's say simple getter property. Oops. Let me use my little copy here. Equals 10, which it cannot. It's read-only. But suppose we had done something like, let's define a var behind the scenes int equals 10. Let's say that this returns behind the scenes. This is a case where the property itself, simple getter property, is read-only, but because somebody else can change this, so somebody else could say behind the scenes equals 20, right? And then when we ask for simple getter property 2, we get a different value. So in this case, simple getter property 2 is not immutable, but it is read-only. It just so happens that we're reading something else behind the scenes. And you're going to come across cases where you're going to intentionally do things like this. It may feel a little bit weird, but typically the reason that you would do this is if you wanted to expose this value as a different type from this property. And maybe this value is being protected by some kind of an object. And so the object itself changes the value, but on the outside, somebody sees this value. And we'll get into cases like that later on. But it's really important just to keep in mind, if something is a val, all that means is it's read-only. It doesn't necessarily mean it's immutable. Being immutable or not depends on what it's doing behind the scenes. Okay, any questions on that? Okay, cool. Let's go ahead and take a 10-minute break. Let's just call it 8:45. We'll start back up again. Okay, let's go ahead and start back up here again. Any questions before I keep going? Okay, so let's take a look at a reason why you might want to use some of this getter and setter overriding. Let's say that I had a variable property here. I'll call it name. I'll say name to log. And I'm going to define that as a string who's going to have no value to start with, just an empty string to start with. And let's say that we want to log, in this case, we're just going to print out whenever somebody reads or writes this property. So I'm going to define a getter here. And this one, I'm going to say return field because I want to have that backing field. And I'm going to define a setter that says field equals value there. So once again, this is just what the default would do. This does the same thing as if I defined name string equals quote quote. So these are completely equivalent, just have different names. But now I'm going to tweak it so that it's actually going to log whenever it's read or write. So I'm going to put in here println reading name to log, and then I'll come down here and say writing name to log. Boom. So now notice that the little warnings are gone because these are no longer equivalent to the default. They're no longer redundant. Um, we're explicitly defining name to log, these actions to perform around there. Note that in both cases I'm using field, but all it takes is if one of those mention field, then it's going to generate that backing field for us. So let's actually use this guy. I'm going to come into here and let's say println name to log. By doing this, this should print out reading name to log and then print that actual value. Then I'm going to say name to log equals Scott. We'll print him again. So I should see here reading name to log, and then it should print out a blank line because there's nothing there. Then I should see it saying writing name to log, and then reading name to log, and then Scott. So let's try running that and see if that does what I expect it to do. So we'll see here, reading name to log, we printed out the initial value, then we're writing it, then we're reading it again, and then we're printing its value. So it's actually going through that code for us. This can be really, really helpful to do extra actions that you want to have happen. Okay, any questions on that? Now let's say that we had something that was like name in database. And I did something like this once for a project where anytime you read or wrote a property, it was actually directly hitting a database. And it was for robustness to make sure that if there was a bug, we didn't lose data. So in a case like this, I'm going to change this to say return value from database. Pretend there was a database call here. So where it says value from database, pretend that that was actually fetched from a database and then returned. And then this guy here, I'm just going to say store value in database. Now, because I'm not referencing field in either the getter or the setter, I don't have a backing field, which means I can't initialize it. And so I just throw that away. So this is a guy here who does not have a spot in memory to hold on to that. He's actually fetching the value from the database and updating the value from the database directly. Okay, let's see, anything else I want to talk about there? No, I don't think so. Okay, so while we're talking about strings, let's go a little bit more detail on strings here. Well, actually, before we do that, let's take a look at this line right here. And notice how int is gray. If I float over that, it says explicitly given type is redundant here. One of the neat things about Kotlin is it's really, really smart on implying type data. So we can figure out just based on the value what type it should be. So if I came into here and let's put it before the hello world. I want that to be the last thing. Let's say I said var z equals 300. Notice that I don't have that colon int anymore, but Kotlin can infer that z is an int based on the value. And that's actually really nice because now we've shortened this thing up quite a bit. I like short. If something's redundant, I don't want to have to type it again. You know, it was really painful for me when I typed these at the beginning of the class because I knew that they weren't needed. And it was typing extra information, and it was like really painful for me to actually try to type those in. But now I'm feeling much happier because it's much, much more concise. But I haven't lost any readability here. Somebody looking at this says var z equals 300. You know what type 300 is. Now there's one little gotcha on this, is if you wanted to assign a value that has one type, but the variable you want to be of a different type. And let's suppose, for example, and I'm going to jump forward just a wee bit here. Let's say that I had, I'll do this class here. Class mammal and class cat is a mammal. And we're going to go into a lot more detail on how the object-oriented stuff works here. But for these guys, what I'm doing is I'm defining a really simple little class hierarchy. So I'm defining some variables can be mammals, and a cat is a specific mammal. And maybe I want to have a dog in there as well. A dog is a specific mammal. And again, if you're not that comfortable with object-oriented programming, we'll get there. But probably most of you already are, so it's not that big a deal. So what I'm doing here is, let's say that I had a var mammal equals create a cat. So if I define this mammal, let's say type of mammal is cat, because the only thing that it can infer here is what you've told it. So sometimes you're going to have situations where you really want to be explicit about the variable. So let's see, type of mammal 1 and mammal 2. And in this case, I'm going to explicitly say it's a mammal. And you notice in this case, it's not saying this is redundant because it recognizes, oh, you've specified a different type there. You want to be able to assign other things to it. Like if I had that be a var and said mammal 2 equals create a dog. We could do something like that. And again, don't worry about the syntax on this. We're going to talk about object-oriented stuff later. But when we have the class name followed by parens, we're just creating an instance of it. So in this case, I'm assigning it to a dog. He originally was assigned to a cat. That worked great. If I tried that with mammal 1, guess what? Boom. It gives an error here saying type mismatch. It thinks that we have to pass a cat in, but we're passing a dog in, and there's no relationship between a cat and dog other than their siblings. But that relationship doesn't mean anything in object-oriented programming. So that won't work. And we'll comment him out there. Okay, so type inference is really super powerful. When you have something like this and you only ever want to assign it to the type that's over here, hey, that's great. You can do that. If you ever want to assign it to something different, maybe the variable is of a superclass and you're assigning a different subclass instance, then you have to explicitly specify it. Okay, any questions on that? And I'll be going into the object-oriented stuff in much more detail later. Okay, so let's take a look. I'm going to go ahead and create a new package here. Oops, not scratch file. And we're going to call it com.javadude.week01.1. I did badly on that. I meant for this one to be the first one and this to be the second one, but hey, but it is what it is. Let's go ahead and create a new Kotlin class file inside there. And I'm going to go ahead and call it main again. And he's going to be a class. Actually, not a class. I just want it to be a file. Boom, there we go. Notice how the package name is different on this guy. So if I mention this main KT, it'll run separately from this guy here. Okay, so inside here, I'm going to type in main, and notice it gives me a couple little options here. A main function or a main function with arguments. I'm going to go ahead and pick the first one here. We could set this up and it would actually, well, I'll go ahead and use that. What the heck? This main function can take some command line arguments, and then we can use those command line arguments, and they're just stored inside an array. We're not going to. I just wanted to show you that there's a different version here that you could use. So here's a main that we're going to use. Let's talk about strings a little bit more. Now, we already saw things like var name string equals Scott. And we'll see that string is redundant. So I'll say name 1. Let's call name 2. We can just go ahead and remove it. And this is vastly preferred. Unless the type really adds more information for you on how you want to use it, go ahead and remove it. Or if the type of, whatever this value is, isn't really obvious when you look at it, when you run it, you may still want to put that in there. So if there's some function that you're calling here to generate something, you might want to put a type on there anyway, just to make it more obvious what you're expecting. That also sets it up so that if the function type changes, it doesn't change the type of the variable name. Now these are very simple strings. These are string literals for Scott. The value is not going to change at all. In fact, we can actually say const, has to be outside of the class here, name3 equals Scott. Let's say const val might help there. There we go. And what this is going to do is this actually ends up getting stored and managed by the compiler in the class file. And so the compiler can basically optimize away references to name3 to this actual literal value. And that can make your code a little bit more efficient in some cases. We're not going to use that too much, but just I like to mention it's there because you can do that. But we can do some more interesting things with strings. Let's say that we want to actually concatenate values together for a string. So let's say that we have val first equals hello, and then last world, something like that. And then val hello world equals first plus last, something like that. And this is basic string concatenation. And what this is going to do is this is going to pull those pieces together. It's going to get the value of first. It's going to tack on the string comma space, and then it's going to get the value of last and tack that on. And so if I println this, let's go ahead and run him. We get hello world. Exciting, huh? Now, if we want to run this one from our Gradle script, I can come over here to my build.gradle.kts and change this to be the new package name. And so now when I run this, whoops, I just ran the main KT directly. Let's go to the terminal here. When I do a Gradle W run, boom, I see just that guy run instead of if I had mentioned him, I get all the stuff that I was doing before. Okay, so we got him. Let's come back to this guy here. But you'll notice how it has the squiggles under here. If I float over this, it's going to say string concatenation can be converted to a template. So let's use a template version of this. And this I think is really awesome. Using template. And what I'm going to do here is hold down Alt and hit Enter on there. And it's going to give me this option, convert concatenation to template. And you can do that when you click in here. Anytime you see this little light bulb appear, you could click on the light bulb or hit whatever the key is. Now, Control-1 is an Eclipse key for it, but Alt-Enter also works. And then say convert concatenation to template, and boom, $first, comma, $last. Now that's much, much nicer, much more readable. And what it's going to do is it's going to evaluate that variable and actually place them in there. Pretty neat. I like that a lot. Let's say that we want to be a little bit more complex on that. Maybe what I want to do is just take the first two characters of each of first and last. So what I can do is I'm going to use an expression here to say get a substring of that. So I can put in dot substring from 0 to 2. And notice when I put that in, it added in some curly braces around that for us. I take him there, and I paste him over there. But notice here, because I wasn't typing it, it didn't add the curly braces in. Let's see what's going to happen with the way I've written it right now. So we're going to do a println. Oh, come on, fingers. That guy there, and let's go ahead and run him. Notice how it has the first two characters of the hello, that's great, but then it has the word world dot substring. What's happening here is when it takes a look at this string, the $sign will keep going until the word runs out, until there's something that's going to break it. In this case, dot is a breaking character for it because there's, last dot is not a valid identifier. Last is, so it'll keep going until it finds an identifier. The difference here is when I have the dollar, it's going to explicitly look for that closed curly and then treat the entire thing as an expression to evaluate there. So this is what we really want, and I can run it, and then we'll see that substring, hey, whoa. Now, there's going to be times when you need to do this even if you don't have an expression. Like let's say that we wanted to have it print out a certain set of numbers of things with an S on the end of it. So if I had val n equals 10, well, no, that's not what I meant. Let's say that we had something like the type of things equals animal. And maybe we wanted to do something kind of like val number of things equals 10. And maybe what we want to do is have val message equals there are dollar number of things, dollar type of things with an S on the end. And notice that's a problem. Because I wanted to pluralize it, I knew that, I would probably put this inside an if statement, but we haven't talked about if statements yet. But we want to actually have more than one. We wanted to pluralize it. And by putting that S on the end, it doesn't work. It looks now like type of things is the actual variable name. So instead, this is one of those places where I'm going to need to explicitly put curly braces around just the variable name and then put the S afterwards. And so now, if I print out that message, we should see that coming up right. There are 10 animals versus there is, and I'll be kind of cheaty here, only one. Not that you would ever write code that looked like this. Something like that. Now you'll see that it's also flagging me here saying, hey, the curly braces are redundant because you don't need them there. And I can remove them. And let's make that be message 2 and that be message 1. And we'll run that. And there we go. There are 10 animals or there is one animal. So once we get talking about like control structures, like if expressions and things like that, we could actually do this inside of an if expression or inside a function and do this same kind of like adding the S on the end based on how many items there actually are. Okay, any questions so far? Okay, so string templates are pretty nice in themselves, but you can do even more with them. There are things called raw strings. And these ones actually will let you encode new lines inside of them. So I could say message 3 equals quote, 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 and 3 quotes at the end. And notice when I hit enter, it adds this little trim indent. I'm going to talk about him in a second here. But this allows me to do a multi-line message inside of here. So I could do something like copyright 2024, Scott Stanchfield, all rights reserved, and some other license text here. So I could actually do something kind of like this, and the new lines will be kept here. So when I print this guy, message 3, we'll see that it's printing those out with new lines and with the space inside there, or whatever space is inside there. That's really nice. But let's talk about this trim indent. You'll notice over here, these leading spaces are gone. It's just starting off with the copyright text. So any space that was happening before these guys is actually getting trimmed. That's what trim indent does. We can do something similar by using trim margin if we want to be very explicit. And by default, the margin indicator is a vertical bar. So I could do something kind of like this. And this is explicitly saying where the indentation is. And so if I wanted to, I could do something kind of like this. And then, oops, make this message 4. And run him. And we'll see that now I've kept the indentation exactly as I wanted it. If, by the way, I'd done this with trim indent, I would have actually had the same result. Whoops. What just happened? Okay. Zoom was getting in the way there. So if I change this to be message 5 and had this be trim indent like that, let's watch what happens here. Notice how it worked out just fine. In this particular case, the trim indent is going to find the least indent and then indent based on that. So the least indent will be removed. This next section here is kept. Sometimes that works, sometimes it doesn't. It depends on how you want the first line. Is it the first line? Let me just try something here. I was just thinking maybe it's just the first line it looks at. No, it's taking the least. So it takes the least indent and strips that, which is what I thought it did. I just wanted to verify that before I'm telling you bad information here. So sometimes trim indent will work. Trim margin is a little bit more explicit so that I think it's a little bit more readable too, especially if you have varying indent. It's really useful if you're writing out source code, for example. Okay, so that's those guys. And you can change the margin if you wanted to by passing in an argument here, kind of like, by default, it's that. And that margin prefix can be anything you want it to be. So you can change that to something different and then use a different character here if you'd like. I don't see that done too often, but sometimes if the text itself, if the vertical bar is an important character, sometimes you'll get rid of that. Okay, any other questions? Okay, so let's take a look at some expressions. So I'm going to create a new package there, week 012. And we'll say new Kotlin class file there. We'll call it main. I'm going to keep it as a file, which just doesn't generate a class for me. And then we'll say main. And let's take a look at doing some simple expressions here. So I'll say val x equals 10, val y equals 20. And then I can say println x plus y. This is the epitome of excitement. 30, wow, actually it did what I wanted it to do. So you can do basic arithmetic with things like this. Let's see, what is the difference I was doing there? Oh, that was just doing it without the type. We can also do this with things that are Boolean values. So let's come into here and we're going to say val done equals false. Val is person equals true. And val result1 equals done and is person. And this is a short circuiting and we'll do a say 1A and 1B. Why not? This is a non-short circuiting and I'm going to talk about what those mean in just a minute. And let's do the same kind of thing for or. Kind of like that. Short circuiting or and a non-short circuiting or. So there's different uses for these. You're not going to see the explicit words and or used very often. Most of the time people are going to use the double ampersand, and for good reason. What this does is when you're doing an AND that's short-circuiting, it's going to try to evaluate the first part of it. And based on that, there's sometimes it can decide it doesn't even need to evaluate the second part. So in this particular one, done is false, right? So there's no way for this AND to be true. So it's going to immediately stop evaluation at that point, which can save you some time depending on how expensive these expressions are. In this case, they're just variables, but these could be function calls. And if they're function calls returning a true or false, there might be a good bit of work going on there to actually decide how do I return true or false. So sometimes having some expression up front that's quicker to evaluate can short circuit and stop evaluating the other side of this guy. Now the AND itself, when you write it out like this, is non-short circuiting. That means it's always going to evaluate both sides and then perform the AND. Anyone have any ideas when that might be useful? Any thoughts? Exactly. So in this particular case, let's say that these were function calls instead of just variables. If there's some kind of a side effect that you always want to have happen, then you want to make sure that both sides are being called. And that's when you'd use the AND. And that's pretty much the only time when you're going to do that. Similar for the OR. In this case, it makes no difference because these are just variables. Or are they? Think about how these guys work. This val, depending on where it's coming from, could have an overridden get, which actually does some functionality or has some side effect to it. That's gross, and generally you want to avoid that, but it is perfectly possible for some code that looks like this to actually run some side effects based on the getter that's defined there. So I don't recommend you use the AND and the OR that are explicit, the non-short circuiting ones. It's really, really, really rare that you're ever going to be tempted to do that or have a real need for it. So in this particular case, with result 2a, done is false. We can't determine the value of the OR just based on the false, because the other side could be true, and in that case, the evaluation of the other side determines what the evaluation of the OR is. So in this short-circuiting one, it's actually going to end up executing both of these just because done is false. If done were true, then the OR would short circuit as well, and it wouldn't have to it wouldn't have to evaluate the other side of that guy. Okay, any questions on that? This is something you don't see in too many languages. And as a matter of fact, I just learned about this today, that there's the spelled out and the spelled out or. It shows you how often I've needed it. I've been coding all these years with it and never had to question it. But it's there if for some reason you want it. Hopefully you won't ever need that depending on how you write your code. I mean, if you're writing your code in a more functional style, you shouldn't ever have side effects like that. Okay, so let's say we wanted to define a couple of variables. We could do something like val x and y are equal. And this is going to be a Boolean. And we're going to initialize it to the value of x equal y. Now, when we take a look at this, it's going to say this condition is always false. Now, why is it saying that? Well, these guys are both vals. At this point in the code, Kotlin knows there's no way they could have any other value. Therefore, I can resolve this at compile time and hardwire that in. And so it's basically trying to tell me here, it's like, did you really mean to do that? Maybe you did something a little wrong, but maybe that is what you wanted it to do. If instead we made these guys be vars, take a look at what's happening now. It's still saying these are always false because, again, at this point in the code, no one has changed these, and these are local variables inside the main, so nothing outside the main can change them either. If, however, we move them up here, notice how that goes away. And it's actually saying this is perfectly fine. It's not something that holds true. Now, how could this possibly be not resolvable at compile time? How can this result not be known as false? Under what circumstances? Assuming I added some more code somewhere. What if something else were running at the same time this main were running? Maybe main kicks off something up top here that runs in the background. In a case like that, these values here could be modified from both the main and from that other thing. And so at this point in the code, we don't know if the values was 10 and 20, or maybe by the time it reached there, that other piece of code modified these. This is one of the reasons why vals are so much nicer than vars. Kotlin's really, really nice about dealing with telling you about potential places where data could have changed. And we're going to see some examples of that a little bit later. If I did something kind of like, let's say if x equals 10, let's see, can I force this? No, I'll think of a scenario a little bit later. But we're going to see some other scenarios later where if something were running potentially in another thread, we could get different results. Yeah, this is not the example I'd want to show that in. Well, let me just try that real quick here. If x equal 10, then no, that's not going to do what I want to do. I'll come back to that later. We're going to see some examples of what I wanted to show you a little bit later. Okay, and we can do the same kind of thing here for not equal. And we'll just change that into a not equal sign, which is bang equal versus equal equal. So there's some simple expressions there. Now, also in these cases, this Boolean could go away, right? Because we can infer the type from that evaluation. So let's take a look at how we might want to increment stuff. Let's say we had a var n is 10. We can do a post increment or a pre-increment on that. Or we can say n plus equals 2, for example, something like that. And let me explain what these guys do. First of all, I don't recommend you ever use these guys as an expression. We could do something like, actually, no, can we? I think we can, yeah. So we say val m equals n plus plus, or val, let's say m1, m2 equals plus plus n. Do not do this. Pre-increment and post-increment are confusing to start with when people read these. There's a big difference between what these two statements do. If I did, let me put these up here first. Whoops. If I have this code here, what's going to be the value of M1? Anyone? 10 is correct. What the post increment does, that's where the plus plus is after, is it says the value of this expression is just the variable. So it's whatever the current value of n is. And then after I've gotten that value, increment n. So what's going to happen is after this line, m1 is going to be 10, n is going to be 11. Now what about this next line down here? What's going to happen here? Any idea what m2 is going to be? Any idea? This is called a pre-increment. It would be 12. Because what the pre-increment does, it says the value of this expression is the number incremented. And we're incrementing the number. So basically what we're doing here is we increment the number, then return the value, versus return the value, then increment the number. So in this case, both are going to end up being 12. Now, there was enough pause there and enough, kind of iffiness on the answers I heard there that, yeah, this is not something that's obvious. And we've had it since C++. I mean, it's actually, I can't remember. Do we have this in C? I can't remember if this was in C. It might have been in C. God, that seems like so long ago. It was. This has been around for a while, but it's still tricky for people to understand. So don't do this. Don't use ++n as an expression. And then up here, we can say, don't use n++ as an expression. If instead, use it like a statement, and the preferred is the post increment, but either one will work. What if we had val m3 equals n? That seems pretty obvious now, right? So at this point, n was 12, 13, 14. It'll now be 14. And it's much more obvious when you use these by themselves, regardless of which form you use, it's fairly readable. Somebody can look at it and say, okay, we're just incrementing n. Then we explicitly say when we're actually using it. So this is something I'd advise you to do. Don't use n++ or ++n as part of an expression. Don't use it on the right-hand side of an assignment, for example. Or also don't use it as a argument to a function. Like if I was calling some function n or some function foo, if I said foo with n++, that gets kind of tricky to reason about. Because you're actually passing the current value of n and then incrementing it. Now you'll see it's kind of debatable if you have an array if you should use the n++ syntax on that. Because sometimes people will use that to, like, as they're walking through a loop, increment each part. I'm still not super fan of that. Instead, do your n++ and then call foo with n, which in this case, there's a different effect, right? Well, actually, this would be the equivalent.